Hi, this is TJ and welcome back to my channel. Today I have a tip on deburring, and in this video I'm gonna show you how we can create a deburring operation in difficult to reach areas on a park. And when I say difficult to reach, I just want to focus on some undercut areas in a park that we cannot engage. We cannot use a convenient chamfering tool. We have to use a special tool with special toolpath. And here I have a part on the screen. You can take a look and you will see what I mean. Okay, this is a tube style part with two operations. The first operation we make on the left, and after the first operation we flip the part 180 degrees to machine the second operation. And you can see what we run here. The material is a tube, and we cut this profile, this round profile, and we make this flat area, and after that we make this small hole at the top. Okay, and after the first operation we flip part and we finish it with cutting this big hole. Okay, so we have two operations, and we have a potential problem that after we cut this profile and this hole, we have a lot of burr created in this area, inside of the tube here and here. I'm gonna make a curve so you can easily see. Alright, here. So when we cut this profile, we have some burr here and here, but in the top we can easily remove the burr using a chamfering tool, but we have some undercut area here, and also here we cannot remove the burr in these areas, so we need a special method. Okay, and also here, because this is the same part, so after the first operation we don't need to deburr here because we already deburr it here in the first operation, so we just need to deburr this big edges of this hole. So okay, I'm gonna turn on the section view so you can see it clearly. Alright, we have some undercut area here, here, and here, and I'm gonna use a special toolpath. This is secret toolpath. Need some trick behind it to get a toolpath, but basically it's a 3D contour with a deburr. So you can see this is a tool. Let's take a look on the tool I use. This is a carbide deburr. You can easily find it in the hardware store, but I think it's better to use a solid carbide lollipop cutter, so we have more space for working. Okay, you can see this is a tool mounted on a holder. This tool had a steel shank and a carbide tip. It's not so rigid, but I make this for my friend, and he unable to find a better tool, so we use what he got. We use this tool. Okay, and you can see this is the secret toolpath. I deburred it with this tool. Okay, you can see the tool cut into the material here, and it removed the burr from the edge. Okay, really close. Turn off the section, you can see it. Yep, and we also have here, turn on a section. Alright, you can see the tool cut into the material, and we have a deburring operation. Yeah, and we do the same for the right side. Right here you can see how the tool is cut into the part, and it makes the deburring operation. I think it's better to use a lollipop cutter because we have a smaller neck and we have a bigger tip here, so we have a shallow chamfer areas, shallow deburring area, because you can see the contact point here, it's quite steep because of the contact point is quite steep like this. But I believe we can get a better result with a lollipop cutter, not a deburrer. Okay. Yeah, it looks simple, but the tip is how you can create this contour tool path, how we find the path for the tool. Yeah, that's the key for this video. Let's take a look on the level. Here I have a level number 2 with contain my my tool path. Turn on. Alright, you can see I have curve here, a curve here, and a curve here. So how I created this curve for the contour tool path, because you can see here my 3D contour tool path use the curve for guiding. Okay, and this will follow this curve. You can see the tool tip will follow this curve, and it will contact with the part and create the deburring operation. See that? You can see the tool tip will follow this curve. So the question is how we create this curve, how we can create this curve. Okay, it's quite easy but take some time, but I'm gonna show you. Right, I'm gonna turn on the tool path entity. Okay, for easy to see, I will make a copy of this part, and I work on a copy, and then you can easily see. Okay, I translate it about maybe 50 millimeter. Okay, I just translate the part for demonstration. In fact, you don't need to translate it. I just want to work on a new part so you can see the strategy, the process, how it's go. Okay, so how we can create a curve for the tool. Okay, so this is the tip. We use a flow. Sorry, before we can create a tool path, we need to go to solid, and we will make a small fillet on the edge. On the edges we want to make the deburring. Okay, in this case I want to deburr this one, and this one, and this one. Okay, I will make a small fillet. It's just around 0.3. Okay, I will use the 0.3 radius fillet. In this case, it depends on how big you want to cut, how much material you want to remove, and how big is your tool. In this case, I just want to remove the burr, so I don't need a big radius here. Okay, you can see. Oh, sorry. Pick this, and pick this, and we apply the 0.3 radius. You can see this is the radius we just created. Level, plane, front. I'm gonna turn on the section view so you can see. Yeah, you can see this is the fillet we just created right here and right here. Okay, after we get the fillet, we gonna make a flow line toolpath on this fillet. Flow line, go to toolpath and flow line, we select. Okay, I try with this one first. Pum 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 pum. I select this fillet surface. Okay, and selection, and then I check the flow line direction. Okay, this is the direction of the tool, so we accept it. I don't want to use this direction. I want to use this direction, so it's follow the surface. It follow the edge. Okay, and then I select my tool, my deburring tool, and because this is undercut area, so we need some special adjustment. All right. We go to surface parameter, input some parameter here, but it's not important this step. You just ignore it, it's not so important. Okay, we go to the finish flow line parameter. You can input the tolerance for the cut, so I want to make a smooth cut, so I want a small tolerance value. Okay, and step over control, you may want 0.3 or 0.2. It depends on the chamfer. We just use the value and then we test it. If you feel it's not so good, we adjust it. Okay, for the cutting method, I select zigzag, and because this is the undercut area, so we need to make this in the motion gap size keep tune down here. We need to uncheck this one, so the toolpath can be generated because this is undercut area. Okay, so we need to uncheck this option, and then ping ping, and now we wait for the calculation. All right. Boop. Oh, sorry, I used the wrong T-plane. I need to switch it to top plane, top. All right, we generate it again. Alright, we got it. So you can see this in my flow line toolpath. We just use the flow line toolpath for generating this curve. You can see this is the trace of the tool center. Yeah, this is the path of the tool center. We just use the flow line toolpath to get this path. You can see we have more than 2 paths here. For this part, you can see the contact point is the outside of the fillet, so we don't want to use this part, and we go to the next one. So this is the second part. This is the second pass, you can see, and we have a different contact point between the tool and the part. Let's see where is it. Yeah, you can see we have another contact point. So maybe the second pass is better than the first pass, so we will keep the second pass and we remove the first pass. And how to do that, I'm gonna show you right now. For the third pass, we don't have a completely pass, so we skip it. If it's not so good, you can try to reduce this value so you get more passes and you get more option to choice. You get more option. All right. Let's see. Yeah, after we review the step over, we had 1, 2, 3, and 4. Yeah, we have 4 passes, so you have more option. Let's try. Let's see how about the third pass. Yeah, it's look good for this one. So you take a note and you will keep the third pass here. I don't want to backplot so many paths. Okay, I want to stop here, and then we have a special option, this button. This function allow you to save the toolpath as entity, so we can convert this part to wireframe entity, and we can use this save geometry for our contour toolpath. I just want to stop here, and then we can save these parts as geometry. So we save it, and we will save it to number 2. This is the level I store my toolpath entity. Okay, save it, and then we turn on the level 2. You can see this is my old entity, so just forget it. So this is the new entity we just saved. I turn on the park, as you can see it clearly. This now become the wireframe, so we can select it for our contour toolpath. Now you see how it works, right? We remove the unnecessary curve here, and we remove the left. Okay, we keep the third curve, right? Now we remove the rest. You remember this is the third part of the flow light toolpath. We want to keep it because it has a good contact point to the part. First, second, and this is the third part. You can see the third pass. We have a good, it's quite good contacting area, so it can remove the burr. So we keep that pass. Okay. You see, that's how I create a curve for my 3D toolpath, and we do the same for these edges and these edges. We can use this flow light toolpath again. Now we remove the previous surface, and we select a new one, this one. Okay, check the flow line direction. Okay, and you can keep the distance, the step over distance. If it's not so good, you can change it, but I prefer using a small value, so we have more option to choose. Okay. For easy to see, I would turn on the section view, so you can see, you can clearly see the contact point of the tool. This is the first pass. We don't have a good contact point, so we move to the second pass and see how it cut into the part like this. It's still not so good, so I move to the third pass. We look from the front and see. I think it's okay now. We will keep the third pass and we remove the other pass. Alright, I just want to backplot it here, and when it retract, I stop it and save the geometry. Okay, save it to level 2. Okay, level 2 here. Okay, now we remove the unnecessary curve. Remove it and remove it, and we can remove the rest. We just want to keep the third pass of the toolpath. Remove it, and remove the rest. You can see this is a rapid move, convert to entity, so that's what you have. Right. Okay, now I got the curve for the second entity. This curve, I'm gonna use this one for my 3D contour toolpath, and we do the same way for this one. Click on the flow line, remove the old surface, select a new one, checking the flow line direction. Okay, and after that we generated flow line toolpath. Okay, and then we backplot it. And select the bed cutting path. You think, okay, we have 3.5 pass here, so you can see for the third pass we have a completely movement, but when we go to the four pass is we cannot have a complete move because we don't have more contact surface here. We don't have more contact surface here, so I'm gonna keep the third pass, right? With the third pass we have a good connection point, contact point right here. You can see how this cut into the edge, and we keep this third pass and we backplot it until it's retract, and then we stop and save it. Okay, we can save it here. We don't need to save the anti-toolpath, we just save what you want. Okay, we save it. And number 2 also. Now we remove unnecessary curve section view. Okay, we only keep the third pass, so we remove the rest. Oh, yep, just delete it. Whoop, whoop. Okay, also here. Oh, alright, so now we add 1, 2, and 3 curve and make it bold so you can easily see. Change it to the red, change it to red color, red, change the color. Okay, so now you see how I created this curve for my 3D toolpath. We can use this for the 3D toolpath because this is actually the path of the tool center, the tool tip. So, and the 3D contour also use the tool tip, so we can use it easily, no problem. Now we get a curve, and what we do is we just create the contour toolpath contour, and you can select this curve. Okay, and we use the same tool. In the compensation type, we just select off, so tool tip will follow the curve we selected. Alright, contour type is 3D, and we check the tool plane, it should be top, and you can use the lead in and lead out if you want. Alright, okay, and for the depth we use 0. We can use feed plane and clearance. Alright, let's see. You can see we have the lead in and go. You can see the tool will follow the surface, and because this is the fielded surface, so actually it's remove the burr when it cut like this. And we have a lead out here. Oh, we have a look at this lead out. It's cut into the part, so maybe I think because of the tool direction. So let's try to use a negative value. Oh, it do not allow it to do that. So let's try 200. Oh, it's not allowed. So in this case we have another way to do that. We can try to select tension. Okay, 3.2, and we just check it again. It's still plugged into the part. So in this case you can create your out, lead in and lead out. Okay, I just created like this and this. Yeah, so it's quite easy. So you don't need to use the lead in and lead out anymore because we already have this curve. Oh, let's check it. Okay, here. Okay, now instead of select this curve, I select a git again, and I select his start from here. Okay, so we have a lead in and lead out we just created, and then we turn off this one, so we can turn off this, and choo, go, 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 go. Okay, you can see we just created our lead in and lead out, so we don't need the lead in and lead out option in the toolpath anymore. So it's very easy, right? Okay, and then you can copy this toolpath and you do the same with this one and this one. Okay, and for this you may want to reactivate the lead in and lead out. Okay, like this. So I have a perpendicular lead in. Okay, let's turn on the section view so you can easily see the section. Alright, you can see this is my lead in, perpendicular lead in. Okay, and then the tool follow the curve we created and it make the deburring operation. It look very nice, right? And we have the same thing here. And okay, so it's quite easy, right? And then after that you can move this curve back to our part if you want, because I want to use this part for setting up the stock, so I don't want to make a fillet on my part, so you will easily see how it cut into the original edges. Oh, okay, so that's how we created the toolpath, how we created deburring toolpath. So you can see this flowlight toolpath, we just use it for generating the path, and then after that we save the path and we use that path for 3D contour. So this flowlight toolpath we don't need it anymore, we can remove it and we keep the rest, the contour toolpath. Okay, and now you can see how it's worked. Okay, turn on section view right here. Go in, and we move to the next one. And okay, go inside and cut it. Okay, let's make an acraism so you can see how is the chamfer look. Acraism. So you can see that this is how the chamfer look like, how the deburring toolpath work. Very nice, right? Okay, and let's take a look on the cross holes here. And try to see. Okay, so this is how it's cut inside. And turn on the section view. so you can see it clearly. Yeah, you can see the chamfer angle is quite steep. If you can use a bigger tool like a 10mm lollipop or something, I think this can be look better. Okay, the angle is still steep, but at least it can remove the burr. Yes, and I think this is the tip for today. It's quite simple, but I think it can help you in some cases. Alright, let's run it again. Choo. 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 Okay, and we're done, and let's see how it's work on a real park. I think my friend, he need to find a better tool for deburring, because this one is not so rigid. It had a steel slang and a carbide tip, so it have high vibration during the cut. Maybe it would be better if he can find a lollipop cutter or some full carbide deburrer. Okay, so that's what I want to show you. Very simple, right? I think it can be a very nice tip, and you can apply it when you need it. Okay, let's see. This is the deburring tool we use. It's not so good because it's quite small with a long overhang, but at that moment my friend, he just can't find this one on hand, so we try with this one. It's a carbide tip, but the slang is steel, so it is not so rigid, and we have some vibration with the deburring operation. But I think later he will find a better tool for this. This one is too small. Okay. And on my hand are the part before and after the deburring operation. You can see a lot of burr has been eliminated, and you can also see the vibration mark here, and the sharp edge has been deburred, so it's quite good. This part has not so important, so we don't expect we get a nice surface of deburring. We just want to remove the burr. That's the main purpose. And you can see when you can take a look through the part, and the burr has been removed all. It looks quite smooth. It just don't care about the chip behind. Okay, and we have a fixture for testing it, and you can see the part is slightly smooth on the fixture, so that's okay. That's accept for this part. Not a super fine part. We just want to remove the burrs. Okay. Thanks for watching, and goodbye for now. See you on my next video.